Okay, in this video, I will introduce you to the concept of relation. Okay, so let me write down relation. Now, I will assume the fact that you have already done set theory. So, keeping that in mind, first what I'll introduce is the concept of Cartesian product. Probably you already know what is a Cartesian product. I will simply do a quick recap. Cartesian product of two sets. Okay. So, suppose we have two non-empty sets, A and B. So, they are two non-empty sets. Then Cartesian product of A and B is denoted by the symbol A cross B. The same cross symbol that we use for product, same here. So, the notation is A cross B. But what is A cross B? Now, A cross B, that is Cartesian product of A and B, is again a set. And the elements of this set are ordered pairs. That is the most important thing. The elements are ordered pairs. So if I want to write it in the set builder form, then what will I write? It is a set of ordered pairs xy such that. So now we'll try to understand what is x, what is y. Now x belongs to capital A and y belongs to capital B. That means in the ordered pair xy, the first element x will always come from the first set A. First set in the sense the set that we write first in the Cartesian product. And the second element of the ordered pair y will come from the second set B, that is second one in the Cartesian product. Let me give you an example. Suppose A has elements say 1, 2 and 3, and B has suppose 4 and 6. Then the Cartesian product of A cross B will be all those ordered pairs such that the first element comes from A and the second element comes from B. So first let us choose the first element of A, 1. So I will pair up 1 with first 4. Then I will pair up 1 with 6. Now 1 is exhausted. Now we'll go to 2. So now 2 I will pair up with 4. 2 I will pair up with 6. Similarly, 3 I will pair up with 4 and 3 I will pair up with 6. So this is how we form the Cartesian product of two sets. Now this is A cross B. Suppose I want to enlist the elements of B cross A. So what will be B cross A in the set builder form if I want to write it? It will be the set containing all the ordered pairs xy such that this time the first element x will come from the first set B and the second element from the second set A. So for the same set of examples, that is A and B written above, if I want to find out the elements of B cross A, it will be first I will take 4. Then I will pair up 4 with 1, 4 with 2, 4 with 3. Now 6 paired up with 1, 6 with 2, 6 with 3. Okay. So after doing this, we will note two important points over here. Note two important points. First is you can see, since you already know that ordered pair xy and yx, they are not the same. So that will imply that A cross B and B cross A as sets, they are not equal sets. As you can see that inside A cross B and B cross A, the elements are all different. 1, 4 is not the same as 4, 1. So the first thing that we notice, Cartesian product is not commutative. They are not equal. Second point that we notice that if number of elements over here, what do we see? Number of elements in A is 3. Number of elements in the set B is 2. And we see number of elements, that is the cardinality of A cross B as well as B cross A is, over here you see A cross B, 3 A is number of elements of A into number of elements B, that is 3 into 2. Same here, 2 into 3 equal to 6. Since multiplication is commutative, multiplication of real numbers is commutative, so number of elements in A cross B and B cross A will be same. That is, these two sets are equivalent. Therefore, A cross B and B cross A, they are equivalent. You can write it like this, equivalent sets. Or in fact, we better use this symbol, not this, equivalent sets, because they have the same number of elements. But since the elements are not the same, we cannot write they are equal. They are not equal. So here it is not equal, right? A cross B and B cross A are not equal. So they are equivalent sets but not equal sets. So these are the two important things that we note regarding Cartesian product. Now, I'm going to generalize the second result. Let number of elements in the set A be P, number of elements in the set B be Q. Then number of elements in the Cartesian product A cross B is P into Q. So this is a general result, always true. Okay. Now we will go to relation. What we mean by relation. So now we come to relation. Now when we do relation, we use two different phrases. Relation from set A to set B. This is one, and the second one I'll come later. Suppose I name it A. Relation from set A to set B. Now, what is this actually? Now, since I have mentioned relation from A to B, so we note that first I have said A, then B. So what we'll do is, first we will consider A cross B, because A is first. So A cross B. Now, since A cross B is a set, as we have seen above, we can form subsets of A cross B. So we'll define relation from A to B as a relation from A to B is a subset of A cross B. Similarly, a relation from B to A is a subset of B cross A. That is, if I say relation is from A to B, then Cartesian product is A cross B. If I say relation is from B to A, then the Cartesian product we consider is B cross A. So let me choose the first case and explain. Let us consider the same set of sets AB that we have written earlier. So we have already written the elements of A cross B over here. You can see A cross B is 1, 4, 1, 6, 2, 4, 2, 6, 3, 4, and 3, 6. So now let me take a subset of A cross B. Suppose I take, so let me just write the sets A and B once more over here. 1, 2, 3, and B is 4 and 6. Now suppose I say I will take a subset from A cross B and I will name that subset as R1. Just a naming convention, R1. So let me choose out of the 3 into 2, 6 elements. Suppose I choose element 1, 4 and suppose 3, 6. So definitely this is a subset of A cross B. Then by definition of relation from A to B, this is a relation from A to B. So I said it is a subset, a subset. So any subset you choose from A cross B will be a relation from A to B. So this is a relation from A to B. Again, suppose I choose a different subset. Suppose I choose R2 as say 2, 4 and 2, 6 and suppose 1, 6. Again, this is a subset of A cross B. So this is so R2 is a relation from A to B. So this is how we define a relation. Now, this is a definition of relation from the set theory point, but we can also explain it pictorially by the help of arrow diagram because that is a little easier to understand. So let me show how I will express the relation R1 by arrow diagram. Suppose this is my set A and this is my set B. So in A, I have 1, I have 2, I have 3. Here I have 4 and I have 6. So suppose I want to show the relation R1. So R1 is 1, 4, 3, 6. So the relation R1 takes 1 to 4 and 3 to 6. 3 to 6. So this is relation R1. Similarly, if I want to show relation R2, then suppose this is A, this is B, 1, 2, 3, 4 and 6. So relation R2 is 2 to 4, then 2 to 6 and then 1 to 6. 1 to 6. So this is R2. So this is how we show relation by arrow diagrams. And we can also express a relation as set, as a subset of A cross B. So this is how we defined relation from set A to B. Now the question is, if I'm given the sets A and B, then how many such relations can I define from A to B? That is the question. So suppose in the above example, we saw that number of elements in A cross B was 3 into 2, 6. So the set, if you look at the Cartesian product A cross B as a set itself, then number of elements in that set is 6. All of them are ordered pairs, but the number of elements is 6. So from set theory, we know that number of subsets of A cross B will be 2 to the power 6. Number of subsets, because you know that if number of elements of a set A is B, then number of subsets is always number of subset of A is always 2 to the power B. So from here we can see that number of subsets of the Cartesian product A cross B is 2 to the power 6. And I have also mentioned that any subset of A cross B is a relation. So if you now combine these two facts, then you can say that if number of subsets is 2 to the power 6, then number of relations is also 2 to the power 6. So this implies that number of relations from A to B will also be 2 to the power 6. So if I want to generalize this result, then what is happening? If number of elements in A is P, number of elements in B is Q, then number of relations possible from A to B will be equal to 2 to the power P into Q, because 2 to the power PQ is actually the number of subsets of A cross B. That is the reason. So we'll memorize this formula. Number of relations possible from set A to set B is 2 to the power PQ. Now you see, any subset of A cross B is a relation from A to B. So you already know that there are two extreme subsets of a set A. First is, you know that empty set or null set is a subset of every set. So let me write it down. First point, null set is a subset of every set. Subset of every set. So in particular, null set is a subset of A cross B also. So if null set is a subset of A cross B, then by definition, it is a relation. So this implies that empty set or null set is also a relation from A to B. So this particular relation we call void relation or empty relation. So this is one. Second is, we know that every set is a subset of itself. So every set is a subset of itself. So A cross B is also a subset of itself. That means if A cross B is a subset of itself, then A cross B is also a relation from A to B. So A cross B is a relation from A to B. And this relation is called, since I have included the whole set A cross B as a relation, so this relation is called the universal relation. Universal relation. So you can see that these are two different extremities. The empty relation has no element in it, and universal relation from A to B consists of all the elements of A cross B. So these are the two extremities. So any other relation will lie between the void and the universal relation. Now, next we'll try to understand what we mean by domain and range of a relation. So let me again take, okay, first let me write down. We want to discuss what is domain and range of a relation from A to B. So as in the earlier example, we had A is 1, 2, 3 and B was 4 and 6. So we have also enlisted the elements of A cross B. Now, let me take a relation like this, say R1 equal to, I can choose any subset of A cross B as my R1. So suppose I choose 3, 4, 2, 6 and suppose 1, 4. So suppose I chose this relation R1. So this is a subset of A cross B and hence a relation from A to B. Now I want to find out what is the domain of this relation R1. So domain of relation R1 is a set, first of all. It is a set consisting of all the first elements of the ordered pairs present within that relation. For example, here the first elements are 3, 2, and 1. So 3, 2, 1. So this is the domain of R1. Similarly, range of the relation R1 is a set consisting of only the second elements. So if I look at the second elements, 4, 6, 4. So since we write repetitive elements once, so it is 4 and 6. So domain and range of the relation R1 is this. Again, suppose, and you can see here that the domain and range coincide with A and B over here. But this may not so happen. Suppose I choose a relation like this, R2. Suppose I choose 1, 4 only. So this is a subset of A cross B. So it is a relation, R2 is a relation from A to B. So now here, if you find the domain of R2, what will it be? So domain of R2 will be 1 and range of R2 will be only 4. So you can see here they are not coinciding with the initial sets AB. So how you choose your ordered pairs inside the relation, that will determine what will be the domain and range of that particular relation. So this is what we mean by domain and range of a relation. So uh, that's more or less the concepts of relation uh, based on set theory as well as from the arrow point diagram. In the next video, I'll try to solve some examples, give some examples and solve some sums. So if you want to see the examples, you have to go to the next one.